Okay, now let's do a problem where I need to find out both the LCM and HCF of fractions. So let's take the question. Find the LCM and HCF of 6 by 8, 2 and half, and 15 by 16. So when I'm getting these fractional numbers, let me check whether they are in their lowest terms or not. So the first number 6 by 8 is not in its lowest term. I can reduce it further by cancelling the numerator and denominator. Both are divisible by 2. So 3 to the 6, 4 to the 8. And I can't divide any further by their common factors. So the lowest term will be 3 by 4. Second number 2 and half. This is a mixed number. Let me change it into an improper fraction. 2 to the 4 plus 1 5 by 2. And the third number is 15 by 16. That remains as it is because this can't be reduced any further. Okay. Now let me find the HCF of these three terms. So let me say the required LCM equals the LCM of the numerator of these three numbers. So LCM of, what are my numerators? I have 3, I have 5, and here 15. 3, 5, 15. LCM of 3, 5, 15. And HCF of the denominator. What are my denominators? Let me check. I have 4, 2, 16. 4, 2, 16. So if I do the LCM of 3, 5 and 15, what will be that? Sorry. Yeah. So 3, 5, 15. I find the LCM. So let me divide by 3 ones are 3, 5 remains, and 3 5s are 15. Next again 5, 1 remains, 5 ones are 5, 5 ones are 5. So my LCM of these three numbers will be 3 into 5. That means 15. And what about the HCF? 4, 2, 16. All the three numbers should be divisible by a common factor. So let me divide by 2. 2 to the 4, 2 ones are 2, 8 to the 16. So I get 2, all these three numbers will be divisible by 2. And I see after that these two numbers will be divisible by 2, but not 1. So I don't need to I don't need to divide any further. I have got my HCF of these three numbers, which is 2. So I can say the required LCM is, LCM I have found 15 divided by 2. So 15 divided by 2 is my LCM, required LCM. And since it is a 15, the numerator is greater than the denominator, I can reduce into a mixed numbers. That will be, let me show it here. That means I divide 15 by 2. So 7 to the 14, which is closer to 15. Subtract 5 minus 4 is 1. So my mixed number is 7 and 1 by 2. This is my LCM. Next I need to find the HCF of, so I can say the required HCF equals, in top I have now, the rule for HCF is HCF of the numerator and LCM of the denominator. So let me check the numerator and denominator. Those were, in the numerator I have 3, 5, 15. So HCF of 3, 5, 15 and LCM of the denominator 4 to 16. 4 to 16. Let me now find the LCM and HCF like before. See that 3, 5, 15. Let me divide by 3. 3 ones are 3, 5 remains, and 3 fives are 15. So you can see not all 3 of them are divisible by 3, right? So I can say HCF is equals to 1 because only by 1 all these 3 numbers are divisible. And what about the HCF? 4 to 16. The LCM of the denominator. Divide by 2. 2 2s are 4. 2 1s are 2. 8 2s are 16. Again divide by 2. 2 1s are 2. 1 remains. 4 2s are 8. And I can't divide any further. So LCM of these 3 numbers in the denominator is 2 into 2 into 4. 2 2s are 4. 4 4s are 16. So I am getting my required HCF equals, HCF I have got 1, LCM I have got 16. So 1 by 16 is the required HCF of these fractions. Okay, so suppose we are asked to find out the LCM of some numbers. Let's write the question. Find the LCM. LCM is what? Least common multiple. LCM of 12, 18, 20 and say 105. What is the common way to find LCM? We write all the numbers I have in this way: 12, 18, 20, 105, right? And then what I do is I start with the smallest number with which at least one number is divisible. So let me start with 2, and I can see 12 is divisible by 2, 18 is divisible by 2, 20 is divisible by 2. So let me proceed. 2 6 are 12, comma 2 9s are 18, comma 2 10s are 20. 105 is not divisible by 2, that's why I'll keep 105 as it is. Next again I'll divide each of these numbers with 2 because I can see 6 is divisible by 2, 5 is divisible by 2. So 3 2s are 6, 9 remains as it is, 5 2s are 10 and 105 remains. Again I divide. Now I can see that none of the number is divisible by 2 anymore, but 3 is divisible by 3, 9 is divisible by 3. So I divide with 3. 3 1s are 3, comma 3 3s are 9, 5 remains, and here see 105 is divisible by 3 because 3 3s are 9 and 3 5s are 15. Next, here again I divide, but see that only 3 will be divisible by 3 and no other number. So, but 5 and 35 will be divisible by 5. So, I divide by 5. First number 1 remains, 3 remains, 5 1s are 5, 5 sevens are 37. And here in this step I don't find any other number, any two number which are divisible by the same numbers. That's why my LCM will be, my required LCM will be the product of all the divisors I have got. That means 2 into 2 into 3 into 5 into 3 into 7, because this one doesn't add up much. I mean, it doesn't change the product if I multiply with 1 or not. So I'll write only the numbers except ones. 2 into 2 into 3 into 5 into 7. And how much does that come? 2 2s are 4, 4 3s are 12, 12 5s are 60, and then 60 into 7 is 7 zeros are 7, 6 sevens are 42. So 420 is my LCM. I'm sorry, I must have missed something. Yeah, there should be 1 3 more, because here this 3 I have missed out. Let me add here, into 3 into 7. So that means with 420 I need to multiply 3 more, and it's not 420. I have to multiply 3 more, and this is my rough work area. So 3 zeros are 0, 3 2s are 6, and 3 4s are 12. So my answer is 1260. This is my LCM. So thus it is required to find the LCM of yeah, for this sum I have got my LCM 1260. Suppose we have a problem where it is asked to find the LCM of take any two numbers, say 42 and 72. How do we find this? At first I do the factorization as I used to do, and 72 here. Let me factor them out. Starting with 2, it is like 2 2 2s are 4, 2 1s are 2, then 3 7s are 21, and here I have 2 3s are 6, I have 12, 6 2s are 12. Then again with 2, it will be 2 1s are 2, 8 2s are 16, again 2 9s are 18, then 3 3s are 9. So I have got the factors. Then I can write 42 equals to what? 42 equals to 2 into 3 into 7, and 72 equals to what? 72 is 2 into 2 into 2 into 3 into 3. What I should look here is that the LCM I have to find out. The LCM must contain every prime factor of each of the numbers, and each of these factors must occur at least as often in the LCM as it occurs in either of the numbers themselves. So the LCM will be what? The lowest common multiple, right? So first I'll check the common things. That means 2 here, 2 here. So I'll take, therefore LCM equals, I have 2 in both the cases, so I'll take 2 ones. Next, I don't have 2 in both the place again, but I have 3 here and 3 here. So for these 3, I can take 3 here once. And then whatever remaining I have, I'll take all of them. That means from the first place I have 7. From the second number I have 2 into 2 into 3. How much do I get? 2 3s are 6. 6 7s are 42. Then 42 into 2 is 2 2s are 4. 4 2s are 8. 84 into 2 is 4 2s are 8. 8 2s are 16. Into 3 is 3 8s are 24. I have 2. 3 6 are 18. Plus 2 is 20. I have 2. 3 1s are 3 plus 2 is 5. So my LCM comes as 504. Okay. How do we find the LCM of fractions? Suppose I am given a question, find the LCM of 8 16 by 20 and 1 and 3 by 7. Now to do this kind of sum, firstly I have to convert all of the terms into a fractional form. That means the first number I can see it's 8, so it is in the numerator I have 8, in the denominator I have 1. Second number is 16 by 20, and third number, this is a mixed number, so I can change it into a proper fraction or improper fraction. So it's 7 1s is 7 plus 3 10, so 10 by 7. Okay, now what's the rule or what's the formula for finding the LCM of fractions? That is, the required LCM equals, I have to do the LCM of the numerator. That means I have 88, 16 and 10. LCM of 8, 16 and 10 and divided by HCF of the denominator. So HCF of 1, 20 and 7. Okay. So now I find the HCF and LCM. So LCM of the numerator, so 8, 16 and 10 I have. So let me find the LCM. Go by 2. 4 2s are 8. 8 2s are 16. 5 2s are 10. Again by 2. 2 2s are 4. 4 2s are 8. 5 remains. Again by 2 I can go. 2 1s are 2. 2 2s are 4 and 5 remains. So what's my LCM? This is 2 into 2 into 2 into 2 into 5, right? So this is 2 2s are 4, 4 2s are 8, 8 2s are 16. 16 into 5 is, it's 16 5s are 80. You can check it by doing the long multiplication, but if you can remember the table of 16, this is 5 16s are 80. Oh, 2 2s are 4, 4 2s are 8, 8 2s are 16. before doing this, let me check once again my numbers. See here that I didn't reduce this fraction. I mean, it can be reduced further, so I should proceed that way. That means this is 16 by 20. I can cancel 16 and 20 by their common factors. That means 4 4s are 16 and 4 5s are 20. That means this fraction will be reduced to 4 by 5, and in that case the required LCM will be equal to LCM of 8, not 16. I should take 4, 8, 4 and 10, and in the denominator not 20 but 5, right? So then if I have let me just redo this LCM portion again. So I have to find the LCM of 8, 4 and 10. 8, 4 and 10. So this is, start with 2. 2 4s are 8. 2 2s are 4. 5 2s are 10. Again go by 2. 2 2s are 4. 2 1s are 2 and 5 remains. So what's the LCM? LCM will be 2 into 2 into 2 into 5, and this is 2 2s are 4, 4 2s are 8, 8 5s are 40. And what's the HCF of those three numbers? See, since I have the numbers are like 1, 5 and 7, seeing them I can easily tell or mentally calculate this, that all these three numbers are only divisible by 1. That means the common factor of these three numbers is 1. So I can say the HCF is 1. So in that case I am getting the LCM as 40 and HCF as 1. So I can say my required HCF is not HCF, my required LCM is, here I have got LCM of these three numbers as 40 and HCF of this is 1. So my required LCM is 40. Okay, suppose I am asked to find out the least number. Find the least number. Find the least number which when divided by 12, 16 and 18 will leave in each case a remainder five. I'm reading the question once again. Find the least number which when divided by 12, 16 and 18 will leave in each case a remainder of 5. What do we do to get the numbers, get that least number? First I find the LCM of these three numbers, right? I have 12, 16, 18. I find the LCM of these three numbers. So 2 6 are 12, 2 8 2 8s are 16, 9 2s are 18. Again I divide by 2, 3 2s are 6, 4 2s are 8 and 9 remains. I have to divide by 3 now. 3 1s are 3, 4 remains and 3 3s are 9. And further I can't divide with divide two numbers. So my LCM will be 2 into 2 into 3 into 4 into 3. That is 2 2s are 4, 4 3s are 12. 12 into 4 is 4 12s are 48. 48 into 3 will be 3 8s are 24. I have 2. 4 3s are 12 plus 2 is 144. So my LCM is 144. So the remainder required, so the number required, because it said there will be a remainder of 5, so the number required equals 144 plus 5. We just add the remainder which will remain. That means how much that will be? 5 plus 4, 9, then 4, then 1. That means 149 is the required number.